Okay, so I'm Juste Raimbault, working at UCL at Center for Advanced Spatial Analysis with my buddy, and I will give some insight into integrated the MATSim Transport Model into DAFNI. So my team is quite well known in the transport community, but just to give a few details, it's disaggregated agent-based model for transport. So it's more like a framework than a model because you've got a lot of different modules and different options. So it's a Java library in the end. But to be able to run it, you need a lot of heterogeneous data and integrate many different submodels, because the MATSim model in itself is just the transport part, and you need to generate the demand and also to do your own data preparation and data post-processing. So this is an example of from the MATSim team, where they set up this huge process of integration. And more generally, if you look at land use transport models, there are also this kind of progressively complexified models where you can couple different submodels and couple different dimensions, and you detail some others. So this is an example from the Wegener review of land use transport model. So the idea of stemming from this is to be able to build some kind of modular transport models from the bottom up, and do this using scientific workflow systems. So you had the DAFNI presentation just before, and DAFNI is one example of scientific workflow systems. Actually, you can use this type of system to couple the different parts needed for the model, and also to integrate with open data. So yeah, that's what we try to just couple the submodels into the workflow. You got some, then you got reproducibility, transparency, and you can also easily share your models and transfer the results. And then, depending on the workflow system, you can also apply some validation methods. So the example I will show just after will be integrated the MATSim Transport Model into DAFNI. It's a kind of work in progress. So the case study is construct a 4-step multimodal transport model using only open source project and open source data. So the core of the transport model is a MATSim model, so developed by the MATSim community, mostly at TU Berlin and ETH. Then, as I already said, you need to generate the demand for transport. So for this, we need also a synthetic population. And synthetic population is generated with the Spencer model. So it's developed by Nick Lomax at the University of Leeds. Yeah, it is a dynamical microsimulation model. It includes both synthetic population generation and also the dynamical projection population. So we use just a synthetic population part of the Spencer model. Then we also need to generate travel demand. We need to have some homework commuting flows, and then to generate plans from these flows. And for this, we use a quant model, which is a spatial interaction model developed at CASA, mostly by Maibati and Richard Milton. And so we use here a re-implementation of this model into Scala. And then we also use an open source library called Spatial Data, developed by the Openmore community for the spatial data pre-processing, all the network stuff, and so on. So the aim is to run the model on any functional urban area in the UK. So we use the Nomus census or non-survey roads transport national dataset. So what is currently integrated is the Spencer model, the quant model. Then we are able to generate networks and plans. Then because you need to have some specific format for MATSim, so it's kind of XML file. And for now we have a one-mode MATSim on the platform. And it was already mentioned, but all of this has are integrated as Docker containers. So maybe I can just give you an insight into how does the script look like when you want to integrate a MATSim. So this is an example of the Docker file when we pull the spatial data library from GitHub, and then we compile it. So it's quite simple. And also for the MATSim in itself model, we already have the compile jar locally, so we just copy them into the Docker, and we then just configure the script and so on. But it's also quite simple to do the Docker file. Then you need to have some run script, so it's also quite simple to do a shell script to run the MATSim. So here you just need to set the config file, and then have the Java command to run the MATSim model. But the idea is that globally you don't need much work to Dockerize your model. And finally, the last step is to create this YAML DAFNI file that Tom already showed. And this is an example for the MATSim model, and it's also quite simple. You specify your outputs of the model and the dataset are required. And all of this, then you're able to integrate it to DAFNI. So I will show the integration. Yeah, the workflow for MATSim is you've got the natural processing, population processing, and then you run the MATSim model, and then you're able to visualize. And I will also briefly show how it is connected. Maybe you can still show it. Yeah, some visualization into the MATSim, into the DAFNI Jupyter notebooks. So here an example of the network visualization. So just checking that the world network is fine. And then visualizing some MATSim output. Here we can, it's a ad hoc visualization for some home workflows obtained from the MATSim runs. Okay, let me go back to my slide. So I showed this. And yeah, some example of large-scale simulation. I run the one-mode model for several urban areas in the UK. So we don't have London here because it took too much time to run. But we had all these large urban areas. And here is an example of distribution of trip distances after the model has converged to some equilibrium, because MATSim model is an iterative a model where agents adapt their plans and try to converge to some kind of equilibrium. We have the same results. So distribution, for example, of trip departure times for the same urban areas. So you can compare. Some are more or less concentrated for the start of trips. And then we also did some sensitivity analysis studies. Looking, for example, for one urban area, so it's a small one here, Taunton, looking how does changing the random seed, so across different stochastic runs, how does it change the distribution, and you got some kind of variability across the runs. Okay, I will go to the conclusion already, so the perspectives. So the next steps will go towards some more advanced spatial sensitivity analysis and some validation of these models. So here is some literature on methods we developed to improve model validation where you've got spatial data. So the idea is to extend traditional spatial sensitivity analysis to the sensitivity to spatial structure. And for this, you need to be able to generate some synthetic data. So here's the two papers on the bottom. And all the corresponding methods are integrated into the spatial data library. So we should be able to use them quite easily. Last point that of a thing that is currently integrated into DAFNI is the Openmore workflow engine. So it's another workflow engine. It's an open source software, but also enables model embedding and access to HPC. But what is useful for us in this case is the exploration and optimization algorithm, so methods to validate models. And so what we were able to do, so for now it's only a test workflows. But what you got in Openmore is are some methods for sensitivity analysis, spatial sensitivity analysis, design of experiments, the calibration, and also more advanced things like diversity search and inverse programs. So what we do, we Dockerize Openmore, and then we integrate Openmore into DAFNI as a model itself. So it's a platform within a platform. But through this, we have access to this advanced sensitivity analysis experiment. And it was an example of a global cell-tele sensitivity analysis run on a domain model. But since we are able to use Openmore into DAFNI, we try to apply this then to the MATSim model. Okay, briefly, because I think I'm short on time. Just current development and application of this MATSim integration. I'm currently trying to finish the multimodal MATSim and having some calibration of the mode choice parameters. For now, it's only running locally. I still need to integrate it and so on. And also, there is a difficulty with visualizing the dynamics of MATSim agents because there are some libraries included into MATSim to visualize, to produce some small films of agent moving and so on. But these are not open and they are paying features. So there is a need here to develop some ad hoc visualization stuff and then to be able to integrate into the notebook infrastructure. And then longer term stuff is to have some strong coupling. I think there was a question of on strong coupling of models. So to be able to combine step by step one model running, then the other. So here it will be a strong coupling of quantum spacer to have to combine dynamical population prediction in time. So for example, in 2050, in the end with the transport with the MATSim model. Okay, then some application of this. The idea in the beginning, and I hope we'll have in the end, is to be able, for example, to quantify densities in public transport, and then we can have some potential indicators to exposure to COVID in public transport. And then we can test policy intervention and so on the dynamics of the transport system. Just to conclude, the idea is really to have an open and reproducible and validated urban model as elementary bricks toward larger integrated models. And here there is a central role of the workflow system of the DAFNI platform here. First, yes, the workflow system of the platform enables us to couple model and to construct the model in itself. Then having direct access to the data is quite useful for the integration. And finally, the access to computational roadshows is crucial to be able to run all the things I showed run in parallel on the DAFNI platform. So everything is open on the repository if you want the workflow and the Docker files, and also this library for data processing, and yeah, the website for the engines. So that's all for me. So I'm a bit short on time.